All right, so we are finally to solving equations that involve logarithms and or exponential equations. So we need to remember a bunch of our rules. This is the one that we go from exponential form to logarithmic form and back and forth. The IFF, that might be new notation for you. That literally stands for if and only if. This is an if-then statement, if this, then this, but it's also an if this, then this. So it's an if-then that goes both ways, much more powerful. We like those. And we'll also need to remember all of our other logarithmic rules as we do this. So let's just jump into this. After the next two sections, last two recordings for chapter 6 are word problems involved. In fact, we have one word problem today, but it's not too bad. All right, I'm going to start down here, A. And what I'm going to do right at the get-go is I'm going to convert this from logarithmic form. Now I want to point out A in this case is the 2. Y in this case is the 7x plus 5. And the x in this case is the 5. So here's how this is going to work. This becomes 7x plus 5 equals 2 to the 5th power. So I just use that rule there. And which is 32, subtract a 5 to both sides, 7x equals, you'll want your calculator handy for most of these actually. So 32 minus 5, 27, x equals 27 over 7. Part B. So we're here. Now I'm going to notice I'm adding in between. That means that I can, by the way, notice I'm base 10 on this one, it's missing. So remember, if the base is missing, that's a default that it's base 10. So using a log rule, this becomes x times x plus 5 equals 2. And now I'm going to do the this again. I'm going to change it from logarithmic form. Again, remembering that that's base 10 down there. I'm going to also distribute that x. So this gives me x squared plus 5x equals 10 to the 2nd power. And I'm going to move that over. X squared plus 5x minus 100 equals 0. And that does not factor. So we're going to have to use the quadratic formula here. So we get -5 plus or minus the square root, 25 plus 400, 2, -5 plus or minus root 425. I'm sure that simplifies, but I don't care. And we can only keep the negative answer is going to be a problem because we can't take the log of a negative value. And you can see -5 minus something divided by 2 is going to give me a negative. So we actually can only keep the positive version. So only positive version. So x, ooh, can't see that. X equals -5 plus root 425 over 2. And usually mathematicians want exact answers. We could get a decimal approximation, but we're going to move on. So I'm going to go all the way to the top here. So let's save that off there. Part C. Again, we're log base 10, and I'm subtracting this time. This becomes x plus 5 over x plus 2. Now, when we solve these, we're going to have to be careful and make sure that we are not trying to take the log of a negative value after we get our answers. I'm once again going to use this to change it from logarithmic form, base 10 in this case, because it's missing, into exponential form. So this becomes x plus 5 over x plus 2 equals 10 to the 2nd power, which is 100. Multiply both sides by the x plus 2. This is 100. So x times 100 is at 100x plus 200. Moving that over, that's negative 99x. Moving that over, that is 195. And get x equals negative 195 over 99. Now we have a problem. Let's plug that in to here. We'll do it here. So log of negative 195 divided by 99 plus 2. Oh, we're fine. Oh, barely. Let's double check it here as well. Negative 195 divided by 99 plus 5. Oh, if this one's fine, this one should be fine. Oh, I need the log of the previous answer. Yeah, that's fine. Great. I was thinking we were going to have to throw it out. Nice. Over here. D. So this one's very much like B here. So I'm going to make this into a single logarithm. Log base 2 of, and because that becomes multiply, I'm going to go ahead and multiply it x squared minus 6x equals 4. And once again, I'm going to convert it from logarithmic form into exponential form. X squared minus 6x equals 2 to the 4th power, which is 32. So this becomes x squared minus 6x minus 32 equals 0. And 16, pardon me. 16, not 32. If it was to the 5th power, it'd be 32. I believe this factors into x minus 8, x plus 2 equals 0. Let's verify that. Yep, we're good. So x equals 8 or negative 2. Now, we have a problem. When I take the negative 2 and I plug it into there, log of a negative, no go. I thought that was going to be a problem there, but it wasn't. So that one's out. There's only one answer for this one. X equals 8. All right, part E. We do no space. Push that up. E's ln of x. Oh, let's write that all as one logarithm. That's okay. ln of, and I'm going to multiply that out. X squared minus 6x equals ln of 2x. Now I'm going to use this rule. If the logs are equal, then the domains have to be equal. That means x squared minus 6x has to equal 2x. Cool. So let's move that over. X squared minus 8x equals 0. X times x minus 8 equals 0. X equals 0 or 8. Now, again, we got to make sure that's okay. I'm going to notice when I plug 0 into there, we have a problem. There too, then that'll become a natural log of negative 6. But even this one here, ln of 0 is a problem. So it's definitely out. So 0 is out. So 8 is our guy. All right. F isn't too bad. Let's see if I can squeeze that down here. So here's the thing. I'm going to rewrite, and we'll be using too high. We're going to be using this rule that if the bases are the same, the exponents must be the same. So for F, I'm going to rewrite the 9 as 3 squared. So watch, this is going to be 3 to the 6x minus 9 equals 3 squared. That's 9, right? To the 4x minus 9. And if you remember, when you have a power raised to a power, you multiply them. And you can see the bases are the same. This means that 6x minus 9 is the same as 2 times 4x minus 9. Now I'm going to distribute and solve. 2x, that becomes -9. So for f, we are getting 9/2. Which with exponential functions, we don't have to worry about negatives or positives and all that. Those domains have no boundaries. All right. Last bunch. Let's see if we can squeeze the last ones in here. So we're to F. I may need another piece of paper for the last one. We'll see. So we did F, we are to G. So I'm actually going to convert this from exponential form into logarithmic form, and I'm going to choose the natural log. You can choose whatever base you want, but because it's e here, so this gives me 4x plus 3 equals ln of 1. Now here's something that's kind of cool. ln of 1 is 0. Yay. So this means x equals -3/4. Right, subtract 3, divide by 4. All right, h and I. H isn't too bad, I is a little crazy. So here's what I'm gonna do. I'm gonna use this rule here, where I have two things that are equal, and I can take the log of any base I want to both sides of the equation. So what I'm gonna do here is I'm gonna take the log, it doesn't matter, base 10 or base, the natural log. I'll do natural log. So natural log of 6 raised to the 5x minus 5 power equals ln of 32. And the reason I know I need to apply the logarithm is because what I'm looking for is in an exponent. And when that's the case, then we have to do that. So that comes down 5x minus 5 times ln of 6 equals ln 32. And we need to think of ln of 6 as just some crazy number. We can even see what that crazy number is, ln of 6, right? Just some nutty number. But what I can do is divide both sides by ln of 6. Now I can add 5 and divide by 5. So I get x equals ln of 32 divided by 5 times ln of 6 plus 5. And let me look real quick. Let's go ahead and get a decimal approximation of that. Actually, that's over 5 as well, which becomes a 1. So let's get a decimal approximation. So ln of 32 divided by, now I'm going to be careful, parentheses, 5 times ln of 32 divided by, and I'm using parentheses, 5 times ln of 6, and then plus 1. All right, so this is about 1.3869. Now it'll depend on the problem. If it says to round it to so many places, then you'll have to round it. If otherwise, it's just going to have to leave it as, we could just make this a 1, right? All right, I'm not confident that I have enough space for this last one. So I'm going to use the back of this page. There we go. All right, so this is I. And I'll write the problem out. 7 raised to 2x minus 7 equals 10 raised to the 2x minus 10. Okay, so you may want to start at the top of the page as well. So I'm going to go ahead and take log of both sides. You can do common log or natural log. That's totally up to you. I like natural log, so I'm going to do natural log. And yeah, so I'm going to bring the exponents down. That's the reason I'm taking the logarithm. And I'm actually going to distribute the ln of 7 to both of these and the ln of 10 to both of these. Uh, 2x, both 2x? Indeed they are. Ln of 10 minus 10 ln of 10. Next up, what I'm going to do is I'm going to move all the x terms to the left and the non-x terms to the right. So I'm going to move this whole term here this way, and I'm going to move this whole term that way. Resulting in 2x ln of 7 minus 2x ln of 10 equals 7 ln of 7 minus 10 ln of 10. All right, on the left side, I'm going to factor out an x. And now I'm going to divide all of it by that. So this gives us that x is equal to 7 ln of 7 minus 10 ln of 10 divided by 2 ln of 7 minus 2 ln of 10. And that monstrosity is your answer. Crazy stuff. So you may want to practice that one a few times. It's not hard, it's just very clunky. There's just a lot of writing involved. That's page 1. Thankfully, there's only 2 pages. So, and we only have one problem on this, and it's a word problem. All right, so the population of bacteria is growing according to the equation P of t equals 350 e to the 0.14 t, where t is the number of hours. Estimate the when the population will exceed 788 and accurate to 1 decimal place. Okay, so t is represented in hours. Oh, they tell us that. And that's what we're looking for. So we want to know when P of t equals 788. So this gives us, using this equation here, 788 equals 350 e to the 0.14 t. Again, my goal is to get t by itself. I'm going to divide both sides by the 350. And I'm even going to reduce. Let me show you how to reduce with your graphing calculator. I'm going to go, they're both even, so I know they reduce at least a little bit. So 788 divided by 350. And what I'm going to do before I hit enter, you can do it after you hit enter as well, is I'm going to hit math and I'm going to convert it to a fraction. And it gives me a reduced fraction. So this is 394 over 175. All right, I'm going to convert this from exponential form into logarithmic form using the natural log because I have base e here. This means that 0.14t is equal to the ln of 394 over 175. Now I'm going to divide both sides by the 0.14. Giving us that t is ln of 394 over 175 divided by 0.14. Let's see what we get from that. So I'm going to do the ln of the previous answer. Remember how to do that? That's above there, the ans down here. Second ans equals divided by 0.14. That is a different answer than what my notes say. Let's try that again. ln, I'm going to do 788 divided by 350 equals, that's the same number, divided by 0.14. All right, well, I'm stick with that, I guess. So this is about 5.7969. Oh, it's at around 1 decimal place, so 5.8 hours. All right, that is logarithmic equations.